This will demonstrate partial exchange of BIM model data between 3 users and also show clash detection. We have 3 Blender instances running. The first is going to view the MEP subproject of the design. The second will also view the MEP subproject, and the third Blender instance will be viewing the architecture subproject. We also have a server process running in the middle, which will communicate via ISBM and which will carry out our clash detection and uploading revisions to BIMserver. And here is the BIMserver instance, which will show us a federated view of both the MEP and architecture subprojects, showing the architecture and the MEP instance items. We'll begin editing the MEP project by selecting a pipe, and we'll be moving this pipe upwards so that it clashes with a beam. We'll select the pipe, move it up by 300 millimeters. We now save the file by clicking Save IFC Project. We will then be able to click a custom button on the side called Publish Changes, which will publish the changes to ISBM. Those changes were picked up via ISBM by our server process. The server process is now producing a new model based on the Diff that has been transmitted and doing clash detection. If we go over to our second Blender instance, we should be able to now click another custom button called Check for Changes, which is going to consume the changes from ISBM by receiving a diff, applying that diff to the same base version that the original had, thus producing a new version that is the same as what is in the first Blender instance. It then produces a new version and it marks the moved item in blue. If we check for clashes, it shows us that the item that we moved is also clashed. We can go over to the second Blender instance, click Check for Clashes, and also see that, again, the item that moved was the one that clashed. If we go to the architecture view, we can click Check for Clashes, and we'll find that from the architecture perspective, it's the beam that clashed, highlighted in red. We can also go to BIMserver and refresh the view, and we will see that a new version has been uploaded, and so we can now see the clashing version where the pipe passes through the beam. We can also look at the revisions that have been uploaded for the simple MEP subproject, and we'll see that a new revision was added very recently as a result of applying a diff to the baseline. We can also look at the top-level federated view, and we'll see that there has been clash detection results uploaded as extended data for the top-level project. This has come from running clash detection centrally.